Hello, my name is Alexander Malyshev, and I am one of the developers of Open CASCADE Technology. Open CASCADE Technology, or OCCT, is an open source geometric modeling kernel. It is not an end-user application, but it is actively used as a backend in many open source projects like FreeCAD. If you are not familiar with it, you can watch my previous talk at FOSDEM, where I gave a general outline of the kernel. This year's talk is devoted to two major topics. The first topic is community feedback. Last year we received valuable feedback and we would like to share our actions on that feedback. The second topic is the 7.5 release and what it contains. So let's start with community feedback. GitHub and downloading. Last year at FOSDEM, we received queries about OCCT source code access easing. Earlier, it was necessary to register on our website to download OCCT. This behavior is still present, but there is a good way to get OCCT's source code without registration. An official GitHub contains a mirror of the master branch. There are several ideas behind that decision. First of all, it is public domain. OCCT is available under permissive LGPL license, and it is intuitive to have access to it. No need to register. OCCT releases are marked by tags, so you can download the release of interest without account creation. The repository contains only the master branch, so development branches do not pollute it. As far as I know, there are several hundreds of them, and it makes a difference when you perform git clone. Maintenance simplification. Having direct access to the source code simplifies support of OCCT-related projects. For example, it enables continuous integration or eases package construction for Linux distributions. Contributor license agreement. One headache for our users is the contributor license agreement. In the current approach, you have to download, print and sign a paper document containing contribution terms. After that, it is necessary to scan and put it on a dedicated website or send signed COA via fax. Unfortunately, we cannot get rid of this practice completely, but it is planned to simplify this process. In addition to the old-fashioned COA management style, we are going to introduce a fully digital way of COA signing based on DocuSign. As far as I know, DocuSign is the most popular tool for the electronic signatures in the world. No longer need to deal with paper documents. Testing dataset. This topic is also connected to the contribution process. When an external user develops a patch, they have limited capabilities to test it. OCCT is shipped with a small number of models, and it is possible to launch 30% of tests using this small dataset. Of course, confidential models cannot be shared, but a significant part of shapes can be published, simplifying debugging process. With public shapes, test coverage is around 60%. New website for Open CASCADE Technology. One more issue is messing between Open CASCADE Company and Open CASCADE Technology product, as their names sound similar. Usually, questions about the kernel are asked on the company's website, which is focused on business directions. Here we want to distinguish the company and the product, and it is typical practice. The main advantage is avoidance of interests clashing. OCCT's website is oriented toward free resources, like forum or documentation, while Open CASCADE website focuses on commercial directions and components. Currently, OCCT's website looks outdated, and we are planning to redesign it. The image on the slide presents the new look and feel. By the way, existing user accounts and forums will be merged gracefully, and everything will be available on OCCT's website. In addition to the redesign, there will be new sections added. Projects and products. This section will contain a list of software built on top of Open CASCADE Technology. We have already contacted KiCad, FreeCAD, GBash developers to put these software products in this new section. Research and science. We will put articles that use Open CASCADE technology as a solid groundwork for research. Currently, we have analyzed nearly 1000 articles and this process hasn't been finished yet. If you have an OCCT-backed project or work on a research or a scientific article using it, please share with us the results of your work using contact form to be listed in the new OCCT website sections. Your help here is really appreciated. These are our plans, but what about the schedule? Yeah, the sooner the better, but there are some technical works behind it, so it's not a good idea to promise a date and break the promise. We are going to release an updated website this year, and it is a formal deadline. Testing dataset and the contributor license agreement will be handled after the website update. High entry threshold. OCCT is a huge and complex framework, so the entry threshold is quite high. To ease it, we have reworked our documentation and we have organized it in a more logical manner. We have also updated some samples and have introduced the new ones: Qt-based overview sample and WebGL sample. Qt-based sample demonstrates usage of basic OCCT tools via a set of small code snippets. The figures on the slide show documentation structure in old and new states. The current state of documentation follows the well-known involvement circles concept. It means that you won't jump between chapters, or this process is minimized at least. For example, it was possible to jump between user guides and developer guides, since both contained relevant information for a developer. I hope you will find the new structure to be useful. The second big topic for today is the 7.5 release. In general, the 7.5 release brings more than 400 fixes and corrections distributed over the kernel. In this talk, I just briefly described the most interesting ones, in my humble opinion. So, let's dive into details a bit. General and modeling. Introducing parallel progress indicator. Historically, OCCT kernels are developed for the single-threaded execution, and our kernel is not an exception from this rule. The world moves on, and for us it's the right time to have a parallel progress indicator, enabling parallel workflows. Progress indicator for meshing. Mesher is one of the algorithms in OCCT that supports parallel execution, so the presence of parallel progress indicator is a preliminary requirement for this feature. New triangulation algorithm for planar polygons. We have improved the triangulation algorithm. Now it supports complex concave polygons. You may face this improvement when loading object data. You might know that this format supports not only triangles but polygons as well. Combining these enhancements, one achieves a better meshes experience. Visualization, sRGB. Now our three-dimensional viewer works with sRGB color space. This feature is essential for correct handling of semi-transparent materials, drawing gradients blended in linear color space, not gamma-corrected one. And it is also essential for PBR workflow. PBR, or physically based rendering, is a visualization workflow aiming at fitting shading formulas into constraints of physical laws of light propagation, absorption, and reflection. That is why it is called physically based. The images on the slide demonstrate the difference between standard visualization pipeline and PBR-based visualization. The left image presents standard visualization, and it looks like a plastic object. The right image shows the PBR visualization of a metallic object. It is possible to open a new horizon for realistic visualization, bringing together these two capabilities. Yeah, ray tracing is also available, but it requires powerful hardware for the usage. In contrast, PBR can operate on low-end and mid-end hardware. Data exchange. We continue improving our step translator. The actual release includes advances related to non-ASCII file support and the possibility to read a step document from a stream. The performance of ASCII readers for mesh formats is improved. Also, a writer for GLTF 2.0 is added. The bar chart on the slide presents reading time of big mesh files. In this experiment, I used two different files. The size of STL file is around 320 megabytes, and the size of OPJ file is 185 megabytes. The speedup is nearly 5 times. Personally, I missed this development. When I studied the fix, I realized that the idea consists in the buffer's usage when a file is loaded. Useful links. There are some useful links on the slide which are connected with this talk. For example, additional details on visualization improvements can be found in corresponding blog articles. I'm glad to be here and look forward to coming back. And now I'm ready to answer your questions.
We are looking for tickets from community. We have some internal roadmap. And if you're interested, I can present some and I can highlight some topics that we are thinking of.
Absolutely. This kind of ties in with the question. So maybe you can address that at the same time of how do users, and you have a lot of very dedicated users out there, how do they report community bugs to you? Is the new GitHub the way to do that, or is there still are you still working through the dev.opencascade server that you had been using?
Currently it's possible to report the bugs using only dev opencascade.org website and corresponding Mantis bug tracker. GitHub is some kind of public mirror without big history, a lot of branches, etc., etc. So currently the answer is Mantis bug tracker is a good way for bug reporting.
So, what do you see as what the big elements that Open Cascade is looking at now? The 7.5 brought in a number of these sort of parallel improvements and some really useful ways of bringing that sort of the visualization performance down onto the lower end. Where is Open Cascade looking now for? Is it going to be 7.6 our next release?
The next big release is 7.6. Last Friday we released 7.5.1. It's some kind of bug fix release containing some critical improvements. Actually, I expected this question, and I tried to think about the roadmap for 7.6. I asked my colleagues for help, and as usual, I tried to split the proposed fixes into several groups. First of all, the group called General. We are going to support ARM 64 builds. Apple M1. We are going to introduce some classes for spec trace, dumping and checking. We are going to get rid of deprecated classes like decollection underscore vector. It's some kind of instantiation of corresponding templates and nothing more. From a modeling point of view, it will be just a typical bug fixing, robustness improving, reliability improving, etc. In visualization, we're going to improve compatibility with WebGL, OpenGL ES, support for shadow casting using shadow maps as alternative to ray tracing. we are going to improve performance of rectangular selection. You know that annoying issue when you try to select 10,000 items on the scene and everything hangs. What else? Maybe a prototype Vulkan graphic driver as alternative to OpenGL. From a data exchange point of view, we are going to finalize support of non-ASCII symbols in step parser reader. As far as I know, this job is almost done, but some minor issues remain. Support reading of kinematics entities from step file, GLTF, import-export improvements and fixes for passing validator. Maybe support of meshes. Maybe we are going to add meshes support for a step format. Application framework. It's some kind of, I don't remember. Maybe a possibility to read a document partially. And in documentation, spell check, corrections, and other improvements, maybe something else. That's it that I have in my mind.
So one question from Julian Todd here. So they're asking about texture with unwrapped UV values in addition to the PBR kind of baked in to the GLTF output. So this is trying to facilitate the exports directly in the visualizer without passing it through a sort of external tool like Blender. Is there any? Do you have any thoughts on where that might look in your roadmap? Is it on the map at all?
Actually, as far as I know, no. Maybe our visualization guys, they will see this question and they might think on it, because actually I'm not a visualization guy, so I cannot say anything about it.
Fair enough. Well, how about how about Gordon surface construction? Is this in the pipeline at all? Something that Open Cascade is considering?
As far as I know, we do not support such entities. Usually, we try to follow the step standard, which defines Bezier surfaces and B-spline surfaces and nothing more.
Okay.
Because when you export to external software, you have to convert everything to splines. Internally, we have some Kunz surfaces, as far as I know, and we do not support Gordon surfaces, as far as I know.
Okay. So, speaking of the step export, I saw that you said that the export time has been greatly improved. Is this mostly due to translation, internal translation optimization, or are there other aspects of the step reading and writing that seem to benefit from your parallelization?
Actually, step translator is fully sequential, so the general optimizations here, they are connected to their translation purposes. So currently we do not support parallel mode, but we are thinking of it, because when you have multiple routes in your step file, you can read them in a parallel manner. But the problem here appears when they point to the single entity, which should be processed in a sequential mode to avoid data races.
Right. That makes sense. So the FreeCAD project is obviously a large open source consumer of the Open Cascade library. They maintain a few patches on Open Cascade. It has been kind of, as you noted, kind of a barrier to submitting patches previously. Is that something that is becoming easier now with the opening up, or maybe transitioning some to GitLab or to GitHub? Is there good path for contributors now bringing those patches into Open Cascade?
Actually, in general, we are going to continue using the Mantis bug tracker for a bug as a main bug tracker because it has integration with internal GitLite and other services. We are going to make the barrier smaller. So that's why we are going to use DocuSign. That is why we are going to publish Dataset. That's it.
Okay, so people should continue to get their patches into the Mantis bug tracker if they want kind of the Open Cascade devs to have some visibility on them.
Yeah, it's a typical problem of all projects which have public and commercial public. Of course, we cannot share private models, of course. So that is why somebody of us should take a look at the patch. So check the tests because they may contain proprietary knowledge, proprietary models, etc., etc. So this is the way. So the user can publish a patch. We run internally the testing, and if everything is okay, we integrate it. Otherwise, we have to check at least closed source models and check what's wrong.